Great. Today we're going to talk about chapter 2.4 from just a little bit and 8.1. This section talks about conics, conic sections, and specifically we're going to talk about circles. So conic sections are curves that result from the intersection of a plane and a double cone. The four sections are circle, an ellipse, a parabola, which we've talked about, and a hyperbola. So below here, I've got kind of a picture of what's happening. So you've got your double cone here, kind of one stacked on top of each other, and these will extend on forever. So if I take a plane and just slice it right there, I will end up with a parabola, and these are empty, so they're not full of anything. If I go straight across here, I've got a circle, and if I kind of go at a diagonal but not going out the bottom, an ellipse, and straight up and down would be a hyperbola. So we're going to look at some properties of these, definitions, and just look at these a little more in depth as we move through here. So definitions. So the definition of a parabola, and know that a parabola, ellipse, and a hyperbola are all three special cases of circles. So that's kind of why we're talking about these three a little bit separately than a circle. So a parabola is a set of all points that is equidistant from both a line and a point. So if I have, let's say I've got this line right here, and I've got a point somewhere above it or below it, it doesn't matter. I can create this parabola that will go between the two, such that if I take the distance from the point to the parabola and straight down, okay, this distance and this distance will be the same. Or if I go, from here to here and then straight down, those two distances will be the same. Okay, and that's how you form a parabola. Ellipse. An ellipse is a set of all points, the sum of whose distances to two fixed points is a constant. So again, I've got a fixed point here and here, and I've got some ellipse here. I'm not the best at drawing these. Ooh, that's really bad. Some ellipse here. So that when I take, from here to some point out there down to here, call that D1, D2. D1 plus D2 is some constant. Or I could say, let's pick this point here, track it up to that, and track it to this one. Let's say D3, D4. That when I add those, I get that same constant, whatever it may be. Okay. Hyperbola is very similar, except now instead of the sum, like I wanted with an ellipse, now I want the difference of those distances. So again, I've got two fixed points here and here. There's that side, and then this one's just the same, but upside down, so that if I take, let's say, this point on the hyperbola to there, and then to your other point, and subtract them, so I've got D1 minus D2, I get some constant, which will be the same as, say, if I go to this point to both D3, D4. So D4 minus D3, you got to subtract, and same direction for those constants. So that's what those four are, or those three. And then a circle we'll talk about here in just a little bit. So a general equation, so we'll need to know this here. The general equation, this kind of outlines all four of the conic sections into one equation. And I can get to the others by just maybe rearranging the numbers a little bit. So we're going to use the discriminant, which is b squared minus 4ac, but the letters up here, and these are all supposed to be caps, capital letters. With the quadratic formula, they go with different terms. So notice that a goes with x squared, b goes with xy, and c goes with y squared, which is different than with the quadratic formula. So if we start with a circle, in general, a is 1, c is 1, and b is 0. This is not always true, these three, but for the purpose of this class, I think we'll stick with those rules. So for an ellipse, b squared minus 4ac is less than 0. For a parabola, it's equal to 0. And for a hyperbola, it is greater than 0. Now, with the quadratic formula, these mean different things, but you got to understand that these three letters go with different variables. Okay, so just maybe keep this handy here for our next examples. So determine the type of conic section. So I want to know about b squared minus 4ac. Okay, so I need a, b, c, d, and e, and f. Okay, now remember we'll start with the easy one. F is your constant. So remember, I got to set it equal to 0, so we'll move that one over. So f is minus 1. E goes with y, which is 0. D goes with x, which is 0 because they're not there. C goes with y squared, so here's my y squared. So if I take that out, what's left in my term is 1 over b squared. B goes with xy. Well, I don't have an xy, so that's 0. And a goes with x squared, which is 1 over a squared. So then if I put it into the discriminant, I've got b squared, which is 0, minus 4a, which is 1 over a squared, and and c, which is 1 over b squared. Now then we kind of got to think about what kind of values will I get here. Well, anything squared has got to be positive. So this is a positive, this is a positive, and this is a negative 4. So if I take a negative times a positive, that has to be a negative, which is less than 0. So b squared minus 4ac is less than 0. And from this slide over here, that tells me that it is an ellipse. Okay. Remember, less than 0, it is an ellipse. Okay. Now this one you should know just by looking at it that it's a parabola. But let's kind of use this discriminant here to see that. So A, B, C, D, E, and F. Again, it's got to be equal to 0, so we subtract y. Okay, so my constant is 0, my y is negative 1, my x is 0, my y squared is 0, my xy is 0, and my x squared is 1. Okay, and then we go to b squared minus 4ac. So b is 0, so that's 0 minus 4. A is 1, and c is 0. So that is 0. So my discriminant is equal to 0, which from the last slide. From the last slide here, we know that it's a parabola. Okay. So now the difference between this first one here and this last one is just this negative sign right here. So really, let's just look at A, which is 1 over A squared. B, which is 0, and C, which is negative 1 over B squared. That's all we need, right? B squared minus 4AC. So I've got B squared minus 4AC. That's 0 minus 4, 1 over A squared, negative 1 over B squared. Well, 4 is always negative, or negative 4 is always negative. 1 over A squared is positive, and 1 over B squared is positive, but it's a negative out front. So negative times a positive times a negative has to be positive, which from the definitions of that last slide, we would know has to be a hyperbola. Okay. All right, so we said that all three of those were special cases of a circle. So now we're going to look at a circle. A circle is a set of all points in a plane that are a fixed distance from a point called the center. The center, which is C, is typically denoted by HK, and the fixed distance or radius is denoted by R. So I'm on this XY plane and I've got some point here, HK. If I take the radius and swing it around, that will give me the circle. So we can start by saying that we need the distance formula to find radius. X1 minus X2 squared plus Y1 minus Y2 squared. Okay, and that will find this distance, say, between these 2 points. Let's say this is XY. Okay, radius is the distance. Well, this is the same as the Pythagorean theorem, which is the same as the equation of a circle. So on this next slide here, we've got a couple equations of circles. The first one is a standard equation, and the standard is nice because it gives me two things here. It gives me the center at HK, and it also gives me the radius, which is R. Okay, so that'll really help me graph it. Here, the general equation just sets it equal to 0, and it really doesn't tell me much about what the shape looks like. Remember, we can get this from the general conics equation. Here was your A and your C, and notice I don't have an XY, which was your B. And that's kind of where I got those A equals 1, B equals 0, C equals 1. We have a unit circle, which is centered at 0, 0, and has a radius of 1. We're not going to talk about a lot about the unit circle, but the unit circle is used in trig ratios and those kind of things in a trig pre-calc class. Identify the center and radius of the given circle and graph. Okay, so we've got, we'll just line it up with x minus h squared plus y minus k squared equals r squared. So that's what we're really looking at. Where hk is the center, so I've got 2 and then minus 1. Notice it's the opposite as the center. And the radius, well, r squared is 4, so r is just going to be the square root of 4, which is 2. And then if we go to graph, I'm at 2, minus 1 right here. And then we'll just go up, down, left, right, 2 spots. So 2, 2, 2. So we're here, 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 here. And now I can create a circle by just curving all the way around there. Okay. And then here's my radius, which would be 2. Okay. Not a perfect circle, but that's okay. We get, as long as I can get the idea of what you're trying to draw there. Okay, identify the center and radius of the circle on the graph. So again, same concept. My center will be at 1/2, -1/3, and the radius is the square root of this, which is radical 20, which reduces to 2 radical 5. Now this one's a little bit trickier to graph, so we're just going to do a general idea of my graph. So 1/2, -1, that's in this quadrant. 1/2, -1/3. And this is, you know, somewhere bigger than 2. Radical 5 between 2 and 3. So maybe closer to 2 sides. So maybe this is around 4 or 5, just to be an estimate. So we'll say, you know, something like this, and then we'll be sure to label this radius as 2 radical 5. So that's a general idea of the graph. My point here is so that you understand how to find the center, how to find the radius, and I assume that you can graph a circle from there. So find the equation of a circle with radius 5 and center -2, 3. So in this case, we're going to the equation. Okay, and we're just plugging things in. So radius is 5, so that's 5 squared plus, so again, this is h and k. So I've got x minus a -2, which is plus 2 squared. And you have y minus 3, which reduces that 5 squared plus y minus 3 squared equals 25. So this is standard. Oops. And I can go general if I just multiply these items out. So if I multiply this out, again, that's foiling. I will get x squared plus 4x plus 4 plus, again, we'll FOIL this one, y squared minus 6y plus 9 minus 25 equals 0. And then we just combine and organize a little bit. So x squared plus y squared plus 4x minus 6y. And you got 4 and 9 is 13 minus 25 is minus 12 equals 0. So there's your general equation. So the point 10, -4 lies on a circle centered at 7, -8. Find the general equation of the circle. So I've got some point here on a circle. It's 10 minus 4. And I know the center is 7 minus 8. I'm going to know what's the equation. Well, I have to figure out this line, how long that is that's swinging around there. So I've got x. Remember, this is h and k here. X minus 7 squared plus y plus 8 squared equals my r squared, whatever that is. So we'll use a distance formula here. So distance equals the square root of 10 minus 7 squared plus -4 minus -8 squared. So that's 10 minus 7 is 3. 3 squared is 9. We've got 9. -4 minus -8 is 4. 4 squared is 16. So that's a square root of 25, which is 5. So my radius is 5, so the equation is 5 squared. So general, I want to multiply all this out. So I've got x squared plus minus 14x plus 49 plus y squared plus 16y plus 64 minus 25. So I went ahead and moved that to the other side. So I've got x squared plus y squared minus 14x plus 16y, and then 49, 64 is 113 minus 25 is 88 equals 0. So there's your general equation. So make sure we know the distance formula here for that example. Find the center and radius of a circle. Now this is probably one of the harder problems we'll have in this section. So I need to group this. Well, first I need to get it into standard form. Standard form, that's the x minus h squared plus y minus k squared equals r squared. Why? Because again, this is my center. H and K are my center, and R is my radius, so it gives me the three things I need. So we're going to use completing the square for this. So I'll take x squared minus 8x plus blank plus y squared plus 20y plus blank equals -107. And these blanks have to get added to this other side as well. How do I know what goes on the blank? Well, it's b divided by 2 squared. So here's b, -8, and 20 are my b's. So -8 divided by 2 squared is 16. So I add 16 to the other side as well. And then 20 divided by 2 is 10, squared is 100. Okay. And now with these three I can factor, and with these three I can factor. So I'll get x minus 4 squared, because it's a perfect square, and y plus 10 squared equals, let's see, this is -107, plus 10 is -7, plus 16 is 9. So the center is 4, -10, and the radius is 3. It's the square root of that 9 right there. So that's a circle. So here are your suggested problems. There's two sections here. This is 2.4, okay, which is about circles. And this is 8.1, which is about the conic basics, you know. This equation matches to which one? A circle, ellipse, parabola, and hyperbola. Okay, be ready for your quiz. And that is it. Thanks for watching.